Go on then, CSI, just for you. Evening all. You may have noticed I'm ever so slightly late. Yes, we had family visiting today, and I'm sure you can imagine how that usually goes. Yeah, I'll go on for a bit longer than midnight, make up for my tardiness. Right, let's get cracking into it, shall we? What am I doing? Magellan Class, yes. So back on Friday, we were doing the task system, the ship-wide task system, and we started with working on a cable, getting it to report faults. And I was thinking it might be nice to build on that a little bit and roll it out across the Magellan. But before I do that, I want to work on something slightly experimental to do with the cabling. So what I'm going to do, I'm actually going to make a new test map for this. Let's call it cabling playground. So one of the things we want to do on the Magellan is have each segment of corridor have an isolated segment of cable, which means there's going to be a lot of different bits of cable all over the place. So if we can, rather than having an event-driven system which basically passes the message on and on and on, and having to manually type in the cable name for each individual cable, it would be nice if I could automate that, which means putting in cables is as simply as just as simple as just dropping them in, and as long as the ends are touching, then it will automatically pick up what its downstream cable is, what its upstream cable is, and handle any interface connections from there. So I want to test that and see how well it works in terms of lagging the engine. So if we add basic light, time depending, Anasi, time depending. I'll get the bridge alcoves done for the updates. Whether or not we remove the beam, we're up against it time-wise, and it's starting to rip apart the bridge is going to add at least another week or more to the time scale. We have a floor. Let's give it a better texture. Right then. So if we take our standard electrical cable, I'm going to make a ticky version of it. Now I want duplicate, not delete. So a bunch of this, in fact most of that was the old system for damage effects, which we don't need for now. What we do is we do this this getting all actors and grabbing the name of stuff and grabbing a reference to that by using manually typed in names. Now that's prone to human error and has been the source of many problems. So if instead we had actual connectors, then that would kind of solve that problem. And it just so happens that we do have connectors, because we've got the static meshes that we put at either end of the cable, of the spline mesh cable. So we can use them in the constructor to grab overlapping actors at the other end. So we don't need that at all. Keep that for now. Should be the one, hopefully. Yeah. So basically we want to know which actors are overlapping this cable, and then we can not sure why it needs a transform, but this might be the wrong overlap node. I'll give it a whirl and see. I guess these are all going to be world static. So the idea is we can build the network of electrical devices on construct rather than doing a get all actors on begin play, which means we're handling that sooner, and it means we don't have to do all the manual stuff. Yeah, so if we loop through there, and then we'll just do get class. So if class is equal to this one, then we'll do a thing. And just for debug's sake, let's grab a reference to the class. Yes, I have been working on bug fixing and just general optimization stuff still. We've got a couple of kind of blockers in the bugs, and I really want to get them cleared off. I fixed the customization side of things now, so we no longer have naked characters or characters changing when you sit in chairs. So all of that should be working a lot more efficiently now, and a lot more just a lot more, what's the best way of putting it, like best practice in terms of like multiplayer and how we're handling all of that, moving things off of player controller and onto player state and that sort of thing. Just basically handling it better with the engine. It's one of those things where working and working efficiently are not always the same thing. So we're transitioning between working to working efficiently. Or in some cases, working just about to working properly. Speedy camera. Right, so if I don't connect them up at all a minute, then when we hit play, nothing should be output. I suppose it doesn't help that we're doing it in multiplayer, which we don't want to do. And we just need to make sure we're calling the right messages so that the character pawn gets spawned. So we want to call loading complete. And also galaxy generated. That's kind of the two points in the code where we trigger different things. And that should be enough to trigger the loading of the pawn. Might need a delay in there to make that happen properly. Yeah. Just do a brief delay, and we'll stick a delay in there as well. There we go. Okay, so we have our pawn, we can run around, we can do stuff, and the cables are not saying anything. The helm will have stick controls, so we're going to have it built into the actual armrests of the chair. No, absolutely. The touchscreen controls are going to be for plotting like specific maneuvers. So if you want the ship to roll by a certain number of degrees, you'll be able to input that exactly into the UI. If you're free flying, then you'll use the controllers, the little joysticks on the armrests, which haven't been modelled yet, but there will be some, definitely. And we'll have those linked to like HOTAS input as well, so when you move the controller you'll actually see it move in the character's hand. Because immersion. Right, so both of these should now be reporting a joined cable. No. Okay. So are we getting anything at all? No. Okay. Oh, I think I know why. I bet they're set to no collisions. Yeah, that would be why. So we want to overlap with static and ignore everything else. Yep, so they're set to static, static, should all be set to static. Ah, okay. That's weird. It was working, but now it's not working. And now it's working. Very strange. Okay. Weird. Actually, we don't need that. Right, so downstream device actor would be that. And then we'll just grab the display name for that. And then upstream actor would be that. And we'll get the name to that. Great, okay. So we're getting a reference to those cables. And this is what's going to make our future lives easier, just by removing the need to type stuff in. Now they'll still need an ID at some point, but at least it takes away some of the headache from the setup activity. It also means we can't just have cables floating in midair with this system, because the ends have to be touching. But this is a precursor for things like doing a modular Starship construction where we're bolting pieces together. The ability to physically sniff out the overlapping cable at the other end is kind of part of that. Yes, CSI. So in In a runtime environment, it means that you can plug in a cable to a port and then plug that cable in somewhere else, and then it will already know what's plugged into what, which is particularly useful. Okay, so another thing we're going to need then to test this is a voltage source that's using the same system, and some kind of a light that we can make flash. Yeah, it'll be like Minecraft Redstone, essentially. It will send a pulse every second, and then each cable will then pass that pulse on to the next, and so on. And we can throttle that as required for performance. But what I wanted to do with this is, oh look, it's actually working properly now. It's going to profile like how many cables can we connect together before it starts falling on its face. Because when it comes to the Magellan, obviously the Magellan's a big ship, and if we're doing one cable per corridor segment, we're talking hundreds and hundreds of cables. So we need to be able to make sure that they do indeed perform nicely, because there's going to be a lot of them. Yes, so if we make a test reactor there, what's the best way of doing this? Probably in here, actually. Grab a copy of our interfaces and pop them on there. Yes, we won't bother with any of the tags, because again they shouldn't be needed. We shall grab that. Tidy it up a bit. Of course, this one doesn't have a an input, does it? So, well, it will do at some point, but we'll get rid of that for now, because it will need something for the UI power. If we just chuck power out down there, so don't need to do any of that, which is nice. And it will be pulsing by nature. And we'll do it via a function. So function name is pulse power, once per second, looping. So that's basically us doing a power output, and then have any of that on here. Yeah, we'll just literally just send that. Kind of greatly simplifies this. So we're just basically sending that voltage down the cable once per second, which means we don't need any of that, although I will use that instead. And that, just so that we can control that from the editor. And then we don't need any of that. Right, so that makes that really, really, really simple. We find our connected cable, and then we start pulsing power. Sorry, just losing track of chat there. Yeah, so hopefully we won't need spline cables, at least not for most of the cables, because the corridor ones are all the same curve and the same segment, so I can literally just copy paste all the way around a corridor ring. The idea would be that so rather than pulsing the entire electrical network in one pulse, it would only pulse up to the next box in the chain, which will be the distribution boxes. So they themselves would also be pulsing once per second. So they're only pulsing to their immediately connected cables. So the voltage source that we add to this... Oh, I clicked output log. That was never a good thing. Hang on. Wait for Unreal to have a heart attack a minute. Yeah, so the voltage source here is only going to be updating the current live voltage on the next box in the chain, essentially. Yes, so the idea is you can just run a cable down a corridor to another box, and because we are sending the voltage down as a pulse as opposed to an event-driven process, it makes it much easier to handle like cross connections and things. So just need to make sure that the output port is visible. And the input interface would be there. Right, so plug in, plug out, nice and simple. And for some reason the plugs are over there. That's weird. Whoop. Why are they not moving with the actor? I'm not positioning them in any weird way. Alright, let's attach them. Oh, I see. Right. That'll be why, because that was set to movable and they were not. There we go. Right. Thought I was going mad there for a minute. Okay, so technically that should now be pulsing. Excepting for the fact that got no return path because we're only looking for a particular class here. So we need a list of valid classes. So cable or test PSU. And we'll just expand the list of valid actors. We can make this an array and just see whether the array contains whatever that class is, rather than doing this kind of convoluted OR chain. That should at least add the box. So that's just using our voltage delivery blueprint interface. So that should be received as per normal, and we don't want to do that or that anymore. It's doing that thing where delete has disabled itself, but it doesn't matter. So we're doing a rep notify for the lights, and I think we'll probably simplify this. Because we don't want to be updating that once per second per cable. So we need a nicer way of handling that. We'll maybe do a check to see whether the voltage is there or not, and if the state has changed, then we'll update this rather than doing it every tick. That sends that down there. And then we'll assume that these are not set as end supplies, which means they're handled slightly differently. Wow, spanning tree, that takes me back. Troubleshooting broadcast storms. Always a good day. So I should be able to just add a whole bunch of cables and not having to care about renaming or specifying anything. And then what we'll do at the other end, if we do a duplicate of that box and just make it into a light, I suppose not unlike one of those glowstone blocks in Minecraft. Yeah. Tickleable. So on this one, we want to, I guess we're just responding to that basically. So we don't care about anything else. We should have our electrical interface. Just not going to let me use. Hang on a minute. That should be an event from there. Oh, I remember what I did with this now. So, yeah, so when we send our voltage on this one, is it this one? Yeah, we were handling that slightly differently, but it's not what we want to do. What we want to do is we want to use not that. Yeah, so that function's getting in our way basically. That's what we want. It's my fault for naming them the same thing. So quite simply, for now, we're going to do if that is greater than 0, as in there's something there at all, then we will set the material on this block. So we'll just use a select for this. So there's no voltage, we'll just do default material. That'll do. Otherwise we'll do a red LED. So this is going to need, I guess we don't need the output interface, just need the input interface because we're plugging it in. So we can get rid of that, pop that in there. And we only care about cables on this one. Actually, I don't think we even need to know. At least not yet, anyway. Because at some point we need to send a signal back along the cable so that we can manage things like loads and work out amperages. Okay, nothing bad happened. Right, let's stick a light on the end. Yep. Yeah, it's exactly that. When you haven't touched a system for a couple of years, it really does become a bit of a headache to try and remember what you did. But then I guess that's why you document everything fully. Right, let's make sure we are actually ticking a voltage. Right, so that's going to be sending that much, and then our cable is going to be receiving, well, it's hopefully the same amount. Yeah, so far so good. So we know that that's working. And we know it's working that far. So do we get to there? Okay, so that's each cable reporting receiving voltage. Yeah, so I guess we need to check to see whether the light is actually getting anything. No, I think is the answer to that. Oh, I know why. It's because of the whole the class check we're doing here. Let's check that out a minute. right. It's under actor, that's why I couldn't find it. Right, so we pre-populate this. So we've got cable, tickable, PSU, tickable, and then test light, tickable. Okay, and we'll do if that contains that. Just makes that a little bit more extendable. Okay, so the light came on. Great, yeah, so we're turning it on, and then I think what we'll do is if we delay for 10 milliseconds, then we'll reset that back to default material. No, not that one. Right, there we go. So that's receiving 1 tick of electric once per second. So the question then becomes, how performant can we make it? What's the best way of doing this? So to be honest, I wouldn't expect this to be any less performant because I guess other than the chase that's going to be coming along, because it'll probably take longer than a second to get to the end. Let's find out in a minute. Okay, I think for testing purposes, if we do the same thing with the cable, if we can actually, that is. Grab a reference to the mesh a minute. Then what we'll do is whenever we receive voltage, we'll do the same thing. We'll just set the mesh material and then do a delay. Don't want to interfere with what's going on there, so I'll just do it separately. Oh, I forgot. You can't paste that reference, so it's rubber cable. Why can't I set the material? Yeah, I mean, in an ideal world, the system will be physical. So if you unplug the cable, it's physically no longer there, so the signal will fail. That's generally the idea. Let's make that dim a minute so we can see. Sure why it's not updating the spline mesh, but at the very least that's working. Oh, that's interesting. We've got see, that's not a steady 1 second pulse. Oh, it now is. Ish. Now, it doesn't need to be exact, because what we'll be doing is we'll be basically setting a timer to see whether or not it stops receiving voltage. So if after a given timer length voltage has not been received, then it will turn off as if there was no power. But if one of these cables were, or one of these segments were faulty, that means we can break that one segment and then have that one segment basically showering sparks and things because this is non-functional. We do actually have, or at least we had that capability. So we've got our Niagara system there. Can't remember how I did that now on the last one. Fortunately, I still have the code. Yeah, I think quite simply all we were doing is every time the pulse was received, we'd fire off the Niagara event. For a laugh, let's see whether or not we can do that anyway. Just when it receives voltage. It's exactly what you want to see from your electrical cables. Yeah, so technically it should only be doing that when they're faulty. Yeah, generally speaking, that was the plan. So we were picking random points along the length of the spline, and then we were firing off the spark event. But that is as quick, technically, as the pulse could go. Although I think we are... yeah, actually we are slowing it down artificially. So in order to help with things all broadcasting at the same time, I was sticking in a random delay. So if we take that out a minute, we should see a much faster spark progression. Where is it getting that from? Oh, right, yeah. Okay, now it is going to need slowing down. Just delay a little bit. That's more like it. Right, so this should be consistently flashing once per second now. Yeah, I'd say that's pretty solid. So in terms of fault progression, when something fails at one part of the ship, this is basically how quickly the failure will move throughout the ship. Right, Let's stress it out. One tick, basically. There we go. Now we're hitting the frame rate. Interesting. Right, let's get rid of those Niagara effects a minute. I'm going to assume that it's something to do with start delay and the fact they're all ticking at the same time. So let's just stagger the start. That should be a random float between 0 and 1. Yeah, it obviously didn't like all of them going at once. Okay, well we got 60 FPS. So if we do that as a variable, wrong end. So there should be a pattern there. A tick is whatever the frame rate is, I believe. So basically it's one frame. I wonder why those ones are all hitting together. I was expecting them all to be separated by 10 milliseconds. Well, it's not hitching or causing any issues, so that's promising. Right, so I think what we'll do is if we get... Oh, no, don't do that. We select maybe that lot. I wonder if these ones are, oops, they've lost their reference to the light, or rather they haven't picked up their reference to the light because their constructor has not rerun. So if I move them out of the way and then back, I should have forced the constructor to run again. Yeah. Let's make sure everything's still working. Okay, everything except that one. There's always something, isn't there? Okay, so perhaps doing that in the constructor is not the best place to do it. Interesting. Right, so that should have forced all of them to rerun their constructors. did, and then clearly all of them lost their reference to everything. Yeah, you can see like with these ones, they're only getting that far. So the logic should be fairly straightforward. Okay, so we know we don't want any of that, and we don't want any of that. So if we grab that and don't do it here, do it here instead. So basically, receiving voltage will do nothing until they have identified who they are connected to. Okay, well, that worked for that lot. The same for this one then. We will run that. There we go. Okay. Come on, you can do it. Probably not this specifically. What I'm doing is I'm just basically testing the viability of this, as an approach for just how granular the electrical system is going to be, because if this approach causes hitching, which I fear it might, then we need to continue with the event-driven approach. But the beauty of a system which is running with a pulse like this is that a pulsed system is continually updating itself, which means that if a message is missed, it doesn't matter, because a second later there'll be another one. It's kind of self-healing if there's a drop somewhere in the signal. Hey Baz, this is the test of the electrical system. So we are pulsing an electrical pulse down each cable, and just making sure that this works like en masse performance wise. But we need more. The question we are asking ourselves is, how many until it breaks? Oops. Yeah, so our game thread hasn't gone up at all, so that's good. Yes, having everything else on the ship, definitely. But it's good to be able to test this, just this itself, in isolation, so that we can see whether or not this alone is having any great CPU impact. It isn't yet, but let's see whether we can make it crash. Doesn't help that I can't even see. There we go, it's better. Ooh, didn't like that. Let's try that again. And this is one downside to using splines, because the reason this is struggling so hard is because it's trying to rebuild the spline mesh for every single cable. Come on, you're almost there. Yeah, we're testing out a pulsed electrical system as opposed to an event-driven one. Right, there should be enough separation. Let's give that a whirl. Yes, each one of these is a spline mesh on a spline path. Well, yeah, so the reason we're doing this actually, Alex, is exactly to answer that question. Because normally, to lay this number of cables, I would have to give each one an ID and specifically tell it which cable it's plugged into or which cable it connects to. So I have to do all of these manually. So what it's doing is it's taking the end plugs and doing an overlap test to see what it's overlapping. So it then grabs a reference to the overlapping cable and sends voltage down the line accordingly. And we're still holding steady at 60. And game thread is still... actually, we've probably lost about a millisecond on the game thread. I'd say in terms of the Magellan, that's probably about, I'd say 1 deck's worth of cabling. That's like probably C deck's worth of cabling. Not terrible though. Okay, so we're seeing a 70-80 FPS uncapped. So if we don't do anything, on the PSU, what are we getting? Basically the same. Yeah, so all of that's costing us about 1 millisecond on the game thread by the looks of things. Which, in the grand scheme of things, isn't terrible. Yeah, so basically on begin play, we were doing it on the construction script, but it was getting itself confused. But on begin play, it says, right, what am I connected to? Stores a reference to whatever that is, and then proceeds on the assumption that that's never going to change. At some point, if we have the ability to unplug cables and plug them in elsewhere, then that will have to trigger a tick, basically, until it detects something new, and then that becomes its reference. The event-driven system will be 1 millisecond quicker, because all it would do, although it wouldn't flash like that, so the event-driven system would send voltage down the cable, so say 240 volts, and then whatever device is at the end, it will say, right, I'm receiving 240 volts. Now, that only happens once, and unless the source voltage changes, not the cables nor the hardware at the end are going to do anything or change anything, because the last message they received is that they're getting 240 volts. Which is nice, because the system basically goes idle until something changes. So until the reactor or the batteries output a different voltage, nothing needs to do anything. So the system is essentially free. But the issue with a system like that is it's really, really prone to things happening in the wrong order or a message being missed. Whereas with a system like this, where a pulse is being sent down the cable once per second, if any of those pulses are missed for any reason, it doesn't really matter, because a second later there's another pulse which will probably get through. So it's kind of a self-healing system, which means, like, one of the issues we have at the moment is on computers that have really low FPS, sometimes the loading screen doesn't properly turn on the reactor, so they'll start the game and all the lights are off and the reactor's off, simply because lag caused things to either happen in the wrong order or messages to be missed. Like, this would solve that, because it's updating once per second. Any lag that's causing things to be missed will just be undone, which is good. Yeah, so the cables themselves are not ticking. All they're doing is passing on the message. So they receive voltage, and then 1 frame later they send the voltage to the next cable. This is once per second. So these are essentially reactors, and they're sending out their voltage once per second, and then each cable is updating basically once every frame. So 1 frame later it sends it to this one, then 1 frame later it sends it to this one. So every frame it passes to the next cable. I suppose you could call it a packet, yeah. It is essentially a data packet. This is only half the problem, though. So sending sending a voltage down the cable like this. So this is, we basically just recreated Minecraft Redstone. That's just what this is. We have a source of a signal, the signal traverses down the cable, ends up lighting up something at the other end. Now the issue with a full electrical system is that you either have other factors to bear in mind, like you have things like amperage. So in order to calculate the amperage, you need things at the end reporting the load. So you need to know essentially what the resistance is. So if the resistance is 0, then you've got a short and amperage goes through the roof and the cable melts. So you need a way of sending signals backwards down the cable. So you've basically got data packets going in both directions. So you've got a sending data packet, which is sending voltage, and then you've got a receive data packet, which is actually reporting usage. So basically the wattage on the cable. And we do that by adding up the wattage of all the connected devices. So basically you've got this doubled. So whatever impact this has sending voltage, you double that for the return journey. And then when it comes to things like distribution boxes, what we'll do is we'll have them themselves updating watts per second. So when they receive a voltage from the sending device, say the reactor, so the reactor will send its voltage, and that might be connected to 10 distribution boxes. Each of those 10 will basically tick once per second, and then they'll use whatever voltage or step down voltage they have based on what the reactor last sent them. So they're always working on the last thing they received from the reactor. And then we'll cascade that down. So each corridor will have its own little distribution box, and that will be, again, ticking once per second, and that will just affect those lights, essentially, on that corridor, and doors and things. Yeah. See, I've kind of done that for the current event-driven system, whereas it actually holds a reference to the actual device itself. But what we're doing is we're collating wattages, and then we're combining those. There's some math that you use in order to work out the true amperage on a cable based on like multiple things connecting to it. It's not quite as simple as you take the sum of the wattages. I can't remember the math off the top of my head, but I've got it written down. But we need to calculate that every step of the way. So like you'll have the internal bus on a distribution box basically has its own amperage based on the sum of all the things that are connected to all the cables that's plugged into that box. But then the link between that distribution box and the one upstream, there's an amperage on that cable based on that voltage and that wattage, which is the sum of the wattages of everything connected to that. So it kind of, you have to go step by step backwards through all the distribution boxes because the math changes as you go. Oh, sorry, Max. Hey, Antonio. Which cache are you talking about? I'll have to send some screenshots, I think. I mean, the game doesn't have a saved cache as such. And at least nothing that would prevent VR from working. Because if memory serves, I think you can't even get to the main menu. But then also, if memory serves, I think you're using Airlink on a Quest. Is that right? I haven't tried using Airlink myself yet, so I don't know what the complexities are with that. I mean, I've tried it with a Quest 2 and a Quest 3, and both work cabled via a link cable, but I've never tried it with Airlink. So I don't know if it even works with Airlink. It might not work. Oh, okay. So it definitely works cabled, because my 2 and 3 work. Yeah, without seeing it in front of me, it's hard to troubleshoot without seeing what it's doing. So we know that it definitely does work. But yeah, I guess we need to look at error messages and what it might or might not be saying. The issue with that, Kaji, is so from a corridor ring perspective. Hang on, let's switch to the Magellan map a minute, and I'll show you why I'm doing this. Just give us some ambient lighting a minute. Okay. Right, so taking C deck as an example. So we've got these cables that are coming up and over here, and these are the main supply cables that are coming from the reactor. So we've got basically that lot that are all going up, and then on every deck we break out, which is why there's getting less and less as we go up through the decks. So on each deck we have a distributor behind the wall screen, so it's actually on this side of the wall in the reactor room, and that is all the power cables for each ring in that quadrant. So in this instance we've got one cable there, one cable there, another one that goes up there, and one that goes around, probably around to there. Because the electrical grid is split into the 4 quadrants. So each quadrant has its own isolated grid. So you could damage here without affecting the other 3. So in terms of wiring all that up, what I was going to do was have each of those corridor runs be one cable. So these cables here would be a solid cable that literally go from that box all the way through the corridor, and then the lights would magically connect onto them. What I want to do instead, to make this more realistic and better from an engineering perspective, is to have each corridor segment be an individual. So we've got these, I guess, little bulkheads as you go through. In fact, if we come down here, in fact, let's turn off the interior. easier to see. So these cables running down here are going to be the feed cables for the lights and the doors and things. So each lighting panel is going to have a drop cable that comes down in the wall, and there'll be some kind of a little plug box that they plug into. So the idea was we'll have a little rubber bulkhead between each of these solid plates that essentially turns each one of these into its own single cable. So much as with, I guess, with like household electrics, as much as you'll have a single electrical circuit, that circuit is split into lots and lots of individual runs of cable that are separated by wall sockets, light switches, that sort of thing. So there are plenty of breaks in the cable along the way. So we want to be at the point where like this bit of cable here is damaged. So rather than having to replace the entire cable and have the entire cable light up when you highlight it, we'll just have that bit of cable damaged, and only that bit will light up when you highlight it. So you would remove just this one small piece and then replace that same small piece if you need to. Because if we didn't do it that way, then if this cable was broken, then you could replace this whole cable by removing any one of these wall panels. And we want damage location to be a lot more specific than that. So if the fault is here, then this is the panel you need to remove, and that's the cable you need to fix. It just makes everything a lot more localized. So from a deployment perspective, it's easy to make just a bit of bent cable as a static mesh. So we don't need to use a spline or anything. We'll just use just a simple static mesh, which is more performant anyway, to represent that run of cable. And then we just need to duplicate that around the corridor. And then the same on this side, because all the corridor segments are essentially the same width. Like even the bulkhead here, if you look at it from above, the actual width of that segment is the same. That bulkhead's just sitting within that segment. So by making this into individual segmented cables, deployment becomes a matter of copy-paste, which is nice and simple and straightforward. And then by having those cables automatically identify their neighbor by using overlaps, then I'm not having to go in and introducing the inevitable human error of having to actually type in manual cable references, which is very much what's happening at the moment with the likes of these ones, whereby we have to actually type in here what devices are at the end or each end of the cable. So we're treating it as one solid cable run with a box at each end, and here we're specifying the names of those boxes and indeed the interface that the boxes are connected to. And one of the things we had on one of the Caravella streams is when we were setting up the reactor and all the fluids and everything, and the fuel tanks, it actually took a couple of hours to kind of sanity check all the connectivity, because we were having to sanity check, like, is that cable connected to the right interface, and does it have the right name, and like, is the cable name correct, because this box is looking for the name of the cable by actually looking for the cable that has that tag on it. So from a deployment perspective, it's really, really time consuming, and having to type all this in, again, as you can imagine, from a human error perspective, it's like a minefield, and one typo can stop the whole thing from working. So by having these individual connector meshes looking for overlaps and then finding the cable, it means we don't need to do any of this, and it is just simply a case of plug and play at that point. So that's the rationale behind why we're doing what we're doing. A little bit of work now means a lot less work later, and then we can get this all kind of rolled out and deployed quickly and easily. Yeah, runtime mapping basically. Plug and play connectivity. Oh yes, Claire told me about that series, thank you. You know what, we can fix that right now. I've got so many things that need to be fixed at the moment. So, which one was this? Oh yeah, so basically just need to swap these two around and that will solve that problem. This is all being done properly at some point soon anyway, so that will all get moved about and changed. Ah, thank you for a pace. Yeah, I noticed that. Hang on, where are the controls? Why are they on the frame? Why are they over there? Oh, of course, they're collapsed, aren't they? Yeah, so I think the controls were behind the other UI. So if I bring them forward of it a little bit, maybe not that much. Let's make sure we update that on here because it sets that at runtime. I'll test that before the next build goes out just to make sure. The optimizations for that are a pain. What console was this? It was environment control, wasn't it? I can't even remember what I called the panel. That would be it. Yeah, so the issue we had was that that one is behind it. Although at the same time it's not. So you can see how fiddly it is. So because it's transparent, obviously it's going to look a bit dodgy, but that UI will be a different size once the game's running anyway. I'll leave it slightly proud of that one so that it's clickable. Hopefully that will have fixed it. And then we collapse these down to a single pixel to save on the VRAM. Okay. Yeah, so I'm not going to change the rollout of that cabling yet, because I don't want to break it significantly right before we go out with the demo update. But I will start kind of like the prep work for it, because that is a job that needs doing. We can't start implementing things like wear and tear properly until we've actually got all the hardware in place, and then we can have the NPCs coming and doing their job. But that having been said, where we do have hardware, i.e. these ones, we can start implementing wear and tear on those. So again, our thing for 2026 is going to be a gameplay focus. So we want to make sure that we implement all of the different gameplay elements we need for early access as soon as we can, so that we can get them roughed out, we can get them tested, and we can start getting a handle on which systems we can implement quickly, which are going to require more time, and generally how all of that fits together. So one of the first things I think we'll do for engineering gameplay is implement the wear and tear system. So all the various pipes, cables, distribution boxes, and everything else in engineering is going to start losing health values, and then the engineers, like the NPC engineers for now, will come along and fix them. And if they don't get fixed for a significant amount of time, then eventually that health value will tick to the point where they stop working. I think we'll probably also implement, just for testing for now, just completely random failures. So maybe like once in 1,000 or once in 100, something like that, we'll have a cable just completely fail. We've got no way of like broadcasting that fact at the moment, because we don't have that 3D holo display view of the ship systems. Maybe if we have it on the engineering control panel, or jobs board rather. There's a few ways we can approach that. Sophie, hey, thank you. As always, you are awesome. Thank you very much. Hey, Timmy. Yes, Dave, definitely. So the order of development is most likely going to be sublight stuff first, which will include wormholes, and then we'll start looking at surface sample retrieval and all the science gameplay that goes with that. That's going to have to be kind of a development cycle in its own right, because we'll need to manage the probes, we'll need to manage the removing of stuff from probes, which means we need the procedural item system. So we need to generate procedural stuff. And then we need the science equipment. I think for now, we'll probably just, in the same way that we've done the 3D printers, we'll just have a really, really basic cube with something on it as our science equipment. But at least we can start implementing the gameplay and get that working, and then kind of do a graphical pass on it afterwards and make it look pretty. But at least we can get the gameplay itself working. Yeah, basically. It will spin and it will have a light on it. That will be our science thing for now. Right, so let's start looking at damage. So we want to do this in as performant a way as possible. So we don't want things ticking more than they ought to. So if we load up our cable test map again, we'll add it to the new test ones so that we can test health values. Yeah, for now I'll just spawn wormholes randomly within a system. So prior to moons, they'll just be randomly within a system somewhere. They'll just be an object you can fly to. Once moons are a thing, then yes, wormholes will be one of the things that can orbit a thing. Primarily, it's just me, Chill. We pay contractors for things as and when it's needed, but on a day-to-day basis, it's just me. Just ungroup that lot a minute. Right, so if we hook this into the show debug, then we'll have it start. So every time voltage passes across it, we will reduce its health value. It's probably the easiest way of doing it without having a separate event running, because we want to obviously minimize ticking wherever we can. So the nice thing with voltage delivery is that's something that's already happening, and we know that it's going to happen approximately once per second. So every time that happens, I guess we'll if we make a new function for handling wear and tear, and anything we do on this class is going to be laggy because there are so many of them in the world, and they're all doing spline stuff, so we'll have to deal with the lag and the delays. So manage wear. So there's a few variables that we need to track with this, and they're going to need to be replicated because in a multiplayer environment, if say a client uses an engineering tool on the cable, that tool needs to report back the condition of the cable. So we need to know the health value in multiplayer, and I think we will deduct a random amount of health from the health value every time the cable passes voltage over it. And these kind of things are something that will obviously need to be play tested. So just how much the wear and tear happens, once everything is receiving wear and tear, we'll need to have a look at how quickly things are wearing, and is it making too much work or not? Is it a reasonable amount of wear or not? So if we do maybe, so that would be 1%. So maybe 0.1%. And we will assume, actually, yeah, we're just using 0 to 1, and the reason we're using 0 to 1 is so that we can use the health value as a multiplier. So that would actually have to be, hang on, so 0.01 would be 1%. Yeah, should be it. And then if we are showing debugs, we will print a debug report. Actually, I want to clamp that value, so we don't want it going any higher, any lower than 0 or any higher than 1. Just do that for now. Oh, actually, no. We can do better than that. So if we set broken, so if that is less than or equal to 0, we'll set it as broken. Nice and simple. When we do this properly, we will have a chance of failure based on health. So rather than 0 means broken, like if the health's down to 10%, then the chances of the cable failing completely are much higher. So we'll do like a random dice roll every time to see whether the cable's failing, and then the chance of that dice roll resulting in a failure will just get more and more likely the more the health drops. So it's not quite as simple as health is 0, cable breaks. Just to make it not quite so predictable. But for testing, it can just be 0. Hang on, I'm waiting for it to do its thing. Right, then what we'll do is we will activate our sparkler if it's broken. So to begin with, health won't be dropping very quickly at all. Especially as I didn't actually connect the function. Which would have helped. Let's, for the sake of testing, so it should fail after 10 seconds. Okay, so as soon as that cable breaks, it should start sparking. Okay, and then they are all no longer working because cables are all broke. Of course, they're all broke because I didn't tell it to just break that one. But yeah, it worked. Everything stopped working, so. Yeah, Claire, she does both, so she moans at me for breaking stuff, but she does also cheer when I do something good, so it balances out. Yes, the data cables will work exactly the same way, except the way I'm going to handle the data cables is a far more simplistic. So the pulse that they send is more just a keep alive pulse, really. So like, is the cable connected? Yes or no? As soon as that signal is lost, then data connectivity to that device is lost. As you can see, with the length of time it takes for the signal to reach the light from the power source, we can't have data cables sending actual data packets, because say the RCS thrusters, when you use the helm input for the RCS thruster, the thruster needs to fire instantly, and if you're waiting for the data cable to actually transmit that signal to the thruster, then there's going to be a couple of seconds of delay probably before the signal finally gets there. So the way it will work instead is that when you press the helm control, it will send the signal directly to the thruster, so it's instant. But the thruster will check to see whether or not it actually has data connectivity. And if there's no data connectivity there, then that signal will basically be dropped. So it will refuse the signal from the helm because it doesn't have a data connection. And in order for it to have a data connection, that data cable just has to be pulsing, and it has to be receiving that pulse once per second, just as a keep alive, so it knows it actually has data connectivity. It's rudimentary and it's simple, but it does simulate having data connectivity, and it does mean that if for any reason those data cables are damaged through impact or wear and tear, it means that all of a sudden certain ship systems suddenly won't work anymore, because whilst they physically might be fine, there's no data connectivity, so your commands are not reaching the hardware. So that will be a factor at some point. It's analogous to the electrical cable really, but a much simpler version of it. Now, big metal box, Wi-Fi wouldn't work. Yeah, so none of this needs to happen on the client at all. So all the pulsing is going to be happening on the server. All the client cares about is the replicated variables. So from a client's perspective, it's these. So what's the health of the cable? Is the cable broken? These are the variables that the client will have access to. Whether or not the cable was actually ticking and transmitting that voltage is all handled purely on the server side. Because yeah, you're right, that's a lot of network traffic. But the nice thing is these variables have net coal distance squared on the actor. So on replication here, so this net coal distance squared, that's basically how far the client has to be from this cable in order for these variables to update for that client. So it's not going to be the case that every single cable is going to be replicating its values continuously once per second. They'll only be replicating to clients when the client is near them. So like whether a light is on or off only needs to replicate when the light is near the client. So like, I'd say about 70% of the ship, if not higher, is not going to be replicating to any clients because there's no one in those areas. Some systems will always be replicating. I guess things like the reactor, maybe. We'll have to see. But we do have this. We can control it. We can manage network load by controlling just how far away the client needs to be. And we can also do this deck based as well. So we can game this value by, if the client is not on the same deck as the thing that needs to be replicated, then we can increase, or rather we can reduce this number to make sure that the client is always considered out of range. Like we could set it to like 1 centimeter, which means the client's never going to be in range to get the replication, because they're not on that deck and it's irrelevant. So there are tricks we can do to improve network performance where needed. Obviously that's just, all of that will have to be an optimization pass in and of itself. And we haven't even started with network debugging. That's going to be an interesting one, because we do generate a lot of traffic from a lot of this stuff. So I guess it's the nature of having a giant ship with lots of stuff on it. It all needs to replicate. Dedicated servers are, I would assume, unless I get bored one day and work on it, I would say it's going to be once things are polished. Like we don't really want to start developing dedicated server clients or like a headless client whilst we're still developing the systems, because things might change. So we'll probably get the multiplayer side of things polished, and then we'll look at bringing out a headless client, which will probably just be an additional package on Steam. I'm going to change this based on whether or not we're kind of watching the debug or not. And we'll also randomize that in as well. See, this is where this system can get heavy, because if we're suddenly generating random numbers once per second per cable, then you can see the CPU load is going to start to struggle somewhat. Actually, let's make that an even wider swing. So basically, every time a cable receives a bit of voltage, it will randomly get damaged within that range. And if we're watching it for the debug, then we'll apply a certain specific amount of damage. So obviously the extension of this system is actually what we did last Friday, whereby if this health value drops too low, then a maintenance request needs to be raised for maintenance to be performed on this cable to fix it before it breaks, essentially. Okay, so that cable there, I think it was, is currently ticking down. So 40%, 30, 20, 10%, and broken. So that is now a busted cable, which means that voltage is no longer being passed. I need to stop it from flashing the light. But yeah, so from a repair and maintenance perspective, you know that like the bit of cable that's busted is the one that's sparking. So this one's fine, it's getting all the voltage it wants, and then it's encountering some kind of short here. So when you're looking at this down a corridor, you should see sparks coming out from behind a panel, and that's quite an obvious visual indicator that there's something wrong with that cable. And if we watch it for a minute or so, we might see some of the other ones breaking, although I don't know how quickly they're going to break given the random numbers. Maybe we should increase the chances a minute. Right, so they should fail quite quickly, and not all at once. Actually, and then on the actual lights themselves, rather than having the light turn off after half a second or 10 milliseconds, we'll have them turn off 1.1 seconds after last receiving voltage. So they should all be solid red until things start failing. Well, that's interesting. It means that the voltage is... Oh, hang on. Hang on a minute. We need a retriggerable delay, don't we? Because we want to... obviously we want to reset the delay timer every time, so I should always reset the timer now every time it receives voltage. There we go. Yeah, it's because the timer was turning the light off regardless of new voltage coming in. So what we should see is as individual segments start breaking, like that one, lights should start going out. Oh, yeah, there they go. And it's all broke. Yeah, so we're definitely seeing some frame drop there, but that'll be the Niagara that's doing that. It's interesting actually because we're damaging all of the cables. Like the sparks were over here, and they've slowly worked their way back now to the very first cable, because the first one's broken on all of them. Okay, well, working. The segments only look for their partners once on begin play and then never again. From a performance perspective, I suppose we want to make sure that we only send the sparkles periodically, not like every single tick. Yeah, we get a randomly weighted ball. Then we can say I guess 25% of the time, there will be a Niagara effect. And there's a bunch of other optimizations we can put in here as well. I guess if we had a looping event, we could stop that from happening if the cable is completely damaged. Although that's not really really needed on this one, because there is no looping function. We're just firing a received event. Not impossible, I suppose. Okay, so we should see the faults kind of move from the middle cables back towards the voltage source, and then then those sparks should be kind of randomly intermittent, which is a bit more realistic. Yeah, there we go. So we're not dropping any frames now because it's not trying to fire off all those Niagara effects all at once. It is a fire hazard, and that's kind of the idea, because obviously if something is broken and sparking lots for too long, then there also has to be a chance that a fire is started, and that becomes a whole new problem to deal with. But we do want, cascade failures ultimately. Okay. Alright, so if we're good performance-wise, I suppose the next thing to do is start generating some actual fault tasks from these, and then getting the NPCs to fix them. So if we get rid of that, right, so we're back down to these again. Right, so if we get a nav mesh, let's make that make it a bit smaller. We don't want the NPCs wandering off too far. All the freedom I'm allowing them. Okay, so there's our nav mesh. So each one of these cables, let's break these groups a minute. Yeah, so each one of these should have a child actor, which is the repair position for the NPC. So what they have to do is is they have to navigate to that point in space, and at which point they're in the right position and facing the right way to fix the cable. I guess for now, though, we can just use the location of the actor. And I suppose that's another benefit of not having this as one solid run of cable. We can send the NPC to the actual location of the cable rather than having to add points of interest specifically for them to go to. The cable itself can become a point of interest. Right, so let's add an NPC. So essentially, we want them to free roam whilst there are no tasks on hand, and then when a task presents itself, then they need to go and deal with it. I will flag them for the repair crew. Oops. Now, back 3 years ago, they already had the ability to go and fix stuff, and a lot of that is still there in the code. So when they do a thing, I can find the do a thing. Oh, there we go. Do a thing. There was the repair logic in there. Obviously, I've been experimenting with this, adding the ability to like have shift patterns and things. Right, so that's basically this. So if they're a part of the repair crew, we're looking for things that need fixing, and then we're going blah 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 blah, checking the point of interest, seeing if anyone else is going there. Yeah, and then sending the repair signal. So I'm going to reapproach how this bit specifically works, because this is like 3 years ago code, and we're doing things quite differently now, especially when it comes to how and where we store things, like not storing them on game state anymore. So we're probably going to need an engineering blueprint interface whereby we can signal to these actors that they have in fact been fixed. So the logic there is, so that cable would become broken, or become broken enough that it requires some kind of action. A task is raised for the engineering crew. One of those engineers then picks up that task, navigates to the location of the fault, performs the repair dance, and then the signal is sent to the cable to say, right, you are now fixed. At which point health is reset, task is cleared, and everyone goes about their day. So what we want to see is a cable segment failing, the light going out, NPC coming along, fixing the segment, light coming back on again. That's kind of the process here. And before, we didn't have the whole task system. But now that we do, we need to make sure that all of those systems are now tied together, so that tasks are being generated, NPCs are being tasked, and things are being fixed. I don't know whether we even still have the repair dance. Hang on. I don't think we do. Yeah, because it would be here. I shall have to re-find and re-implement the repair dance. It'll still be around. It never got deleted, so yeah. I'm sure the repair dance can make a return. It really did look stupid, but it was also funny. Okay, I need to get my head around linking all this together now into a cohesive, usable system. Yes, they can, and I see. In fact, this one here specifically is flagged as being part of the repair crew. We had, back at the time that they were actually breaking and repairing things, we had exactly that. So some of them were just free roaming around, going between objects, whilst others were actively going and fixing problems. In some ways that's not relevant now, because tasks that get raised kind of supersede the roaming around anyway. So whether they're roaming around just to do a spot check or whether they're roaming to actually fix something, they're still an engineer in engineering doing a job. So having an isolated repair crew role isn't particularly relevant at this point. So there is our task board. So that's how we can see what tasks we have to do. And we also have the task manager that goes with it. In some ways, I'm tempted to maybe combine these into a unified class, because all this is the output of this, so they need not necessarily be separate classes, but we'll see. We'll see as we experiment with it all. Right, did I have configured things that I needed to... Oh yes. Yeah, so here's a good example of like part of the issue with powering these things, in that this is it's expecting me to type in the name of a cable, which from a testing something perspective is simple enough, but when it comes to actual deployment, it's much easier to have an actual physically connected cable. I think it might be worth making like a powered device master class, and then having everything else inherit from that if they use power. So that'll be from the lights to UI screens to everything really. If it uses power, then it should inherit from that class, because that master class needs to handle all of the stuff that manages the electrical side of the simulation. Kind of, it makes me twitchy kind of doing that, because it means like literally every piece of ship's hardware, every light, the engines, everything, all inheriting from the same class. But ultimately, they do all do the same thing from an electrical perspective, so maybe that's not the end of the world. It just feels bad. Yeah, the electrical system is all set up with interfaces. It's more about the amount of copy paste that's needed. So in order to make this connect to this, obviously I need to give it a power connector, which I shall now do. I'll copy the one from the light. So if we just have a power connector down there, make sure it's in the middle. Okay. So it's already set up to receive voltage, because we've got this. So it's set up to receive that interface, basically. No, it doesn't need to rewrite anything. It would just change the parent class from actor to electrical actor, maybe. But ultimately, this is the only bit of it that's truly relevant, so we can just copy paste this where needed. Because if we're using the pulsed electric, then we don't need to worry about any of this stuff about finding cables, because that's not needed anymore. As soon as electricity is received, that can come with a reference to the sender, so we can send back down the same path. Hey Quickasme, good to see you. Yeah, could well do. I always have problems with those, like referencing the parent actor and sending and receiving stuff between the component and the parent blueprint. But yeah, it's possible. We could just have like bolt-ons as needed, because we'll have the same thing for data, for the fluid system. If each one of those was a blueprint component, then we could just bolt on as needed. Then those can receive the interface and then pass on as needed. Yeah, so as long as the component can use the interface, get the interface message, and then pass that on to the parent blueprint that it's a child of, then yes, that's probably the way forward with it. Okay, so we're going to ignore that for a minute. We've got our voltage coming in there anyway. So in order for that to be powered, and we don't have an upstream cable name, so it needs a physical power connection. So what we'll do is if we grab those, then we'll need to set like an invulnerable flag on this. But then the fun part of this is connecting it up. And why is the connector not visible? Oh, okay, so probably that whole movable, not movable thing. So that should be static, that should be static, and then that is static. There we go. This is my love-hate relationship with splines and the twisting you get. I should snap actually, but yes, thank you. I need to give that a really good once over. So I managed to solve the bulk of these twisting issues. It's when you have something go vertical, it really doesn't like it. There we go, that'll do. So now that that's physically connected, we should have power going to it. Nice, yeah, I'll have a look. Yeah, the twisting problem was driving me mad. So yeah, the reason that's not working, of course, is because we need to add this as a valid class. And again, that's an argument for using a common class as an inheritance chain, is when every time we connect something new to a cable, we need to add that as a valid class within the cable array, which I think over time could probably get quite unwieldy. Yeah, so our overlap classes, we now need to add our task board. Yeah, that's true. Fair point. There we go, it's working now. Looks janky, but it works. Right, so there are no tasks being generated, and the cables are starting to fail. No. Yep, all good. One of the good things about doing the streams is that, you know, being largely a solo dev, I don't have a team around me to bounce ideas off of. So, you know, doing these streams and having people in the stream bouncing ideas is really useful. It's it gives that teamwork that you really need sometimes. Sure thing, Delta. Okay, so we need a reference to that. Then we'll do our random spark. Are we doing? No, we're doing that ourselves. So we need to get a reference for that. So get all actors of class. We can do it with a tag, but let's just do this for now, just for testing. Oh, yeah. Help if you select a class. So engineering. Okay, so that should get our task manager. And then, yeah, we should see a bunch of cables start adding themselves to the task manager for being broken. So these should start breaking in a minute. And then when they do, we should see some tasks on there. Oh, there goes one. Here they go. So there's all the cables breaking. And they're still going. I'm thinking, however, that it's re-raising tasks for cables that it's already done, because there are way more tasks now than there are cables. Yeah, so you got there. So cable 303, cable 303. Yeah, so it's definitely duplicating tasks. So we don't want that. So we're firing create engineering task. Okay. So create engineering task. Oh, see, we're doing add unique. So I was hoping that, but of course we are we're generating a random task ID each time, so that's why it's not unique. Yeah, it's random every time, so we'd have to maybe generate this once, but that's no good either actually, because we need to track it every time. So every time something new happens, we need a different ID. So I'm wondering whether we have a device ID so that we can make sure that we're not raising tasks for the same one, but it's still going to require looping the array of tasks. So we may as well just bite the bullet and for each that. Because even with a unique ID, we're still going to have to do this. So if we break the struct, grab the device, and do the same here. Grab the device. So that is that. So if we're talking about the same device, we don't want to raise fault. So if they do not match, oh, hang on. No. That's not what we want at all. Yeah, so yeah, so what we'll do is we will loop through our current list of tasks, and if at any point we get a match, then we'll remove that as a valid task, and then on completion, if valid task is true, as in it never got set to false, then we will add our task to the array. Yeah, and we'll just set that to true to begin with. So we'll assume it to be true, and then we'll set it to false if there's a match. If it's false, we do nothing. If it's true, we add the task, and that should prevent duplicates. Truth Imkaji, yeah. Yeah, the thing with add unique, if you're doing it with a struct, is that every single element of that struct must match exactly. Otherwise, yeah, it doesn't treat it as unique. That's better. Oh, that one's failing as well. So the interesting thing there, actually, so this cable has now failed, and yet the screen is still on, and it shouldn't be. Yeah, loops are bad. 1, 2, 3, 4. There's way more cables than there are faults being raised. So I think we've optimized too far in the wrong direction. Although it could be the case that no, because all these should, like all of them should have a unique name. Because we're comparing the actor specifically. Interesting. Oh, I know why. It's because once one of the cables fails, nothing beyond that cable is getting ticks anymore. So they can't possibly fail because they're not receiving voltage. So these are the only ones that actually received voltage enough to fail. Let's see if we have that set up. So every tick, we're setting the voltage. Doing our voltage, blah 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 blah. Oh, we're not actually checking to see whether or not it should be on or not. So that should be happening here. So voltage is right. Yes. So the cable is stopping. So it's not telling it that voltage has been received. And this is because of the event-driven nature. So rather than the voltage simply stopping and not getting to the end, it has to continue sending the event down the chain to let the end device know that the voltage is in fact now 0. With a pulsed system, this is not needed because the pulse never reaches the end, which means we never have that problem. So we would need our retriggerable delay, which we can't use in a function because you can't put delays in functions. So I'd have to do that, I suppose, here. So at least for now, we will do a retriggerable delay. So after 1.1 seconds, obviously it's expecting a pulse every single second. If it doesn't receive one, we set the voltage to 0, and then the device should disappear. Let's give that a quick try a minute. So when this cable breaks, the screen should actually go off. So hopefully we'll see some of them raise faults before that one dies. And it's dead. Okay. Which also means then we need an infinite health hack for that particular cable. Okay, so we'll default invulnerable to false. So if we set that one to invulnerable, then it will never die. That's true, AJ. If the taskboard is broken, you can't possibly do any work. Right, so we have reached a point. So I think in order to give this guy less of a headache, we will set the chance of failure back to whether or not we are debugging. So if debug is false, then they'll die at a really slow rate. Otherwise, they'll die quickly. So if we make that one there a debug one, then we'll turn debug off of whatever one we had on. Oh, I think it's one over there, wasn't it? So yeah. Right, let's just make sure that's working a minute. Okay, so that one's broken. Task has been raised. Should have some sparkles. There we go, we have sparkles. Okay. It does look not dissimilar to a bowling alley. Yeah, so the next step in the process is this guy actually grabbing the task. So I think what I'm going to do, because this is going to require modifying some of the NPC code, and I don't want to do that on the live ones because, again, we don't want to break anything unnecessarily because it will affect Claire's blood pressure negatively. Right, so if we duplicate that one, on there. Stick a cat in as well because, you know, why not? Right, so your you're going to be in the engineering department, and you are an engineer. I'm not going to bother with repair crew. So the new NPC logic, essentially, so we've got the whole shift system. So I think we'll just assume them to be on shift for now. Just default that to true a minute. Right, so this is the random actions that we were doing. Yeah, so we were just grabbing points of interest and pathing through them, rather than grabbing an actual task specifically. So we need access to the task board. So let's grab that. Where's our begin play hiding? There we are. Lots of junk going on here. This is one of those blueprints which is crying out, please clean me up, because it's a bit messy. Right, so on begin play, we will simply grab a reference to our engineering task, not task board, our task manager. I need to not get those confused, because the task board is how you display the tasks, the task manager is how you actually get the tasks. Okay, and then we'll store that as our task board. Obviously, as we go through the different divisions aboard the ship, we'll need to get different classes of task manager, but that'll do for now. Right, so that sets our task board. So basically I need to kind of delete most of this. So the free, I am going to delete most of this. So we're not going to bother about bathrooms or anything. Although that said, let's keep that but bypass it. Bypass all of that and start from here. So if we're not dead, it's a good start. So we don't care if we are the repair crew. Nothing about that is relevant anymore. We don't need that specifically. Yeah, so we're grabbing our points of interest from game state, which we no longer want to do. We want to do that via our task manager. Yeah, so really that's the task manager, not the task board. So we'll want to set this up as an interface. Otherwise, we've got to cast to it. I suppose for testing purposes, we'll cast to it anyway, just just to do the test. But I'll make that an interface. No, we're not dead. So we want to get tasks, and then we'll simply get the first one. So that secures us with a task. Right, so we now have a task that we've selected from the task board. We have an ID, so we know which one we can report back with to say it's complete. And more importantly, we know where the task is. So if we get the world location, get actor location, get the world location of that actor, that gives us our pathing location. So we're not going to bother with checking reserve or anything like that yet, because we're just doing a test. Yeah, so we will first of all just grab a copy of that in a minute. Get actor transform. I'll just pop that in there. Okay, so what we want to do, actually before we get one of those, I think what we'll do is we will we'll check to see whether 0 is a valid index, because if it's false then the array is empty. So if it's not a valid index, then we want to free roam. If it is a valid index, then we will grab the details from the struct, and now we can go and walk the NPC there. So none of that is relevant yet, I don't think, although let's hang on, are we doing, yeah we are. Sorry, we're handling the messaging in that, so that's not needed, and that's not needed, and that's not needed. Unless I just deleted the free roam. Oh no, it's there. Great, so we'll do that, and then ultimately we will loop back and do another thing. So we'll get rid of all of that and that. So right now, the NPC will walk to the task location and then just get stuck in a loop trying to do something. And if it's free roaming, it will just do that. So let's pop that down there a minute. So here, what we'll do is, if we're successfully at the vault location, then we need to grab the device, tell it it's fixed, and then pass that back into the queue to get removed from the task list, so the NPC doesn't try and go back to it. Can't remember why we wanted the actor now. Why was that? Oh, right, yes, because of grabbing the data so that we can do some messaging, but that's fine. We will get rid of that because we don't want it for what we're doing. Right, so the NPC should now just roam about the place until there's a fault on that cable, at which point, as soon as the fault's raised, the NPC should then pick up that fault and walk to that location. So there's the fault, and as soon as they're done idling... Oh. Okay, so... yeah, they've done everything I expected of them, so that's good. I delete with a purpose. Well, this is a test blueprint, so doesn't matter what I delete on this one. Although the fact that I've deleted all that and it still works shows you how not needed it was. Just like that's an unnecessary cast, for example. Okay, so the next piece of the puzzle is after we have succeeded, get rid of that a minute. Right, so we have succeeded to get to our point of interest. So we want to fire a repair message to that actor, and again we will do that with a blueprint interface, but for now I will just cast to it because I'm being lazy. In fact, we will delay for a minute, and by a minute I mean 5 seconds. Yeah, so all we need to do is set health back to 1 and set broken back to false. That should fix the cable, but we also want to remove the task from the task board, and for that we're going to have to grab a reference to that again. And I think we'll yeah, so we'll fix the cable first, then we'll clear the task so that the cable doesn't re-raise the task immediately, and then we'll send the NPC off to free roam again. So he should just keep repairing the same cable over and over and over and over. So on the task manager, I'm going to close some of these tabs in a minute, losing track of everything. So we've got create engineering task. We haven't got a remove engineering task. So let's go into our interface. I guess we've got that one, task complete. So that'll do, in fact. So let's just bring up task complete. We've got our task ID. So we will grab our live tasks. We will do a for each loop. And then we will break the struct. And we only want our ID. So if that is equal to that, then we're going to remove index, current index, and why not actually hook that up? Right. So if our incoming task ID is a match for an existing task ID in the array, then remove that index from the array because that task is complete. So from our NPC, we just need to fire off a task complete message and then give it the index of that. So one of them, and then after a brief delay, in fact, if I make that 4 seconds and make that 1 second, then the whole process takes 5 seconds. Okay, fix the cable, clear the task, go and wander. And I noticed the cat wasn't wandering. Why not? Don't know. Hey Don, no, I started an hour late today, so yeah, I'm going a bit longer just to get this system done. I'm not stopping until the NPC is fixing cables. So, okay, fixing. Lights back on. Task is still there. Ooh, I bet that's because it hasn't updated the UI though, because she's still wandering about, so that means there wasn't a task. So it's a UI thing. So yeah, there we go. So she's fixing the cable. Cable is fixed, and then she wanders off. See you, AJ. Have a good one. Thanks for joining, as always. Yeah, I find it's much nicer and easier to test stuff in an isolated environment, because one, it's like instant to load, and two, you can just like see things in isolation. But other than the task disappearing from the UI, I'd say that's working now. Good night, CSI. Have a good one. She did, Max, yeah. She did her magic cable squat, and then a brand new cable was placed. Ah, yes, so that's the missing bit. So we're going to remove the index, but simply removing the index doesn't fire the rep notify. So we need to set that variable as itself to fire the rep notify. And now we can pass the live tasks to the task board, which will cause it to refresh. So we should now see the task disappearing from the board. He says, hopefully. Oh yeah, we haven't got any animations yet. Okay, so cable's broken, task has been raised, cable is being fixed, cable is fixed, task is removed. There we go. So we now successfully have an NPC fixing tasks off of a task board based on those tasks automatically raising themselves based on the health of the cable. And he'll just do that infinitely until he's fixed it. So let's, as a test, so what I want to try is having multiple NPCs and multiple faults. Because in a real world environment, obviously we're going to have a whole bunch of stuff breaking and a whole bunch of people fixing it. So if we make some NPCs, oh, good night, Sirius. Thank you. Glad you enjoyed it. If you check back tomorrow, you should hopefully see a system with multiple NPCs fixing stuff without any overlaps. So we need an assign task. Just thinking the best way to do this. So when we get our list of live tasks. So again, if there are no tasks, we go in free roam. If there are tasks, I think what we'll do at that point is we will, for each loop on those tasks, like even if there's one, and then for each of those, we want to know, is it assigned? And to whom? So we need a boolean for is assigned, and then we could do with an actor reference for the actor or the NPC or player that it's actually assigned to. So, oh, good night, Danger Mouse. Everyone's abandoning ship. Well, hello for tomorrow. Yeah, so because what we'll do is we will loop through the array, and as soon as we find one that's not assigned already, we will grab it, and then the next NPC will obviously skip that one until they're all assigned. Yeah, so that means we need to add to that struct department task system engineering engineering tasks. There we go. Right, so So we want an assigned Boolean. I guess we'll leave it at the bottom, to be honest. And also an assignee, which is going to have to be an actor reference. So we know, is it assigned and who is it assigned to? Now we can use the assignee on the UI because we're passing this data through. So with that, armed with that information, oh hello random green cubes, we can display that on there, which is useful. Those are the points of interest. Not sure why they're suddenly appearing. I'm assuming it's because that just needs compiling. Yeah, there we go. Right, let's do some tab management in a minute. So we want the table, don't need the PSU anymore. Don't need the test light anymore. Don't need the old cable. We do want, no, that's the working one. We don't want that one. We want the task board, we want the task manager, we've got the test NPC and the BPI and the struct. Right, okay. Thank you, Max. I could do with a cup of tea, actually. As nice as this raspberry and rhubarb sparkling spring water is, yeah, tea sounds good. That wasn't a hint, Claire, honest. Right, so if we branch on that, we don't care who the assignee is. Yeah, so all we care about is it assigned. So if it is assigned, we'll just do nothing. If it's not assigned, then we want to claim it. So so we want to take our task manager, extend our spaghetti, okay, so we need to know then our task ID, that should be enough, and then a reference to self. So on here we'll do task ID, which is an integer, and then we'll just do assignee, which is an actor reference. Thank you, Festus. I shall make sure that Claire is showered in chocolates. Oh, I just closed the thing I wanted to edit. Okay, so assigning a task. So we've got our task ID, so we'll have to loop. Oh, and hang on, copy the whole thing just for convenience sake. Right, so if the task matches the task ID, then we want to get a reference. Yeah, get a reference to that index. I always get this wrong when using set members, because obviously that's not a reference, but that is. So we should be able to set members on that specific index, and we want to set assigned and assignee. So assigned is true, assignee is that. Obviously we're only going to do that if it matches. And then we need to set that so that we update the UI. Right, so we're getting a hard reference, setting members, updating that, and that will only happen if we have a matching task ID. Thanks again, Firstus. Claire is also a grape goddess, actually. She eats a lot of grapes. Oh, she said that. Sorry, I'm not keeping up. I don't pay attention. I might condense this into a macro just for like matching task ID, given that we're doing it quite often. Right, so that should handle assignment and then thus the updating of the UI. I'll go through the UI in a sec and actually pull out the name of the assignee and flag it as assigned, because we should then see it assigned on the UI, which would be quite interesting. Right, and then the task board itself, actually no, not that one, that one. So we just need to make sure that we grab a reference to the task ID, and the assignee is a reference to self. So if assignee, if assigned is false, assign the task with this task ID to self, and then go ahead and do all the usual shenanigans of going and actually fixing it. Actually, that needs to be for each loop with break, because we don't want it to keep looping through the struct array, because once we've found an unassigned task, we want to grab it and then not keep going, because otherwise we will assign multiple tasks to ourselves, and that would not be a good thing. So all that needs to be hooked up to that in the spaghetti mother load. I mean, if I was doing this properly, I would assign that to a variable. And I would call it assigned task. And I wouldn't do it there. I'd do it here. Right, and then just to make make this cleaner. So get actor transform, pop that in there. Let's move all this out of the way a minute. Make a custom event. Got cold fingers now, forgotten how to type. Carry out task. So I'll grab a reference to that, grab a reference to that, get rid of the rest. Yeah, there we go. So that just separates this from this. And after it's done that, we can just carry out task. Collapse that a bit, move that over there a bit, tidy that up a bit. Right, so we're assigning our task. If there's not one assigned, yeah, and then that's the task that we're working on, and then we are using that same task ID to complete. Okay, and oh yeah, that's the free roam. We want to leave that as is. Right, so that should in theory be everything we need to assign a non-assigned task. So the next thing we would need to do would be to go to the display board, grab the widget, and then we need also where is it? That the list item. So what have we got here? So rather than target object, I think if we do that as the actor name, and we'll also create a boolean for assigned. It's really, we want to change the background color here. Yeah, and then we'll do that with either boolean. So get assigned user select, pop that in there, which will make our slate colors. Okay, So we're using 0.5 on the opacity. So if assigned is false, then we'll just make it red. And if assigned is true, we shall make it green. Nice and straightforward. And that's going to have to be exposed on spawn so that we can configure that value from here. And so we refresh the task list, blah 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 blah. Refresh that to get our new boolean. Assigned goes straight into there, and we'll convert that to a string, which we will pop into there. Right, so we should see the NPC name and the task change color when they pick it up. We could have them walk to the task board, I suppose, but for now we'll just assign it remotely. But let's just see if any of that works. We've only got one task right now, so we should only see one of them try and grab it. That might still be the case, actually, Firstus. Ooh, green task. And only one of them went to fix it, so that's good. So task is gone. Right, let's see whether it goes red before it goes green. Yep, it went red, then immediately green when someone picked it up. Right, okay. So, that being the case then, let's break a bunch of these. So, show debug, show debug. I suppose we want to make sure we've got one on each row. Okay, that's more tasks than there are people, so the task board should fill up fairly quickly, and we should have we should have 5 green ones, one for each NPC, and then 5, and the rest should be red. Okay, there they go. So we've got 5 assigned tasks, and they're already fixing it. They're playing cable whack-a-mole now. Yeah, the speed of the ship, I think having maybe a slightly higher maximum speed, but also a slightly lower default speed might be the balance we come up with. That 300 light years per hour value is literally our starting point, so we will kind of play test and get a feel for if that's too quick once we have like actual gameplay. Like once we have refueling and all the other bits and pieces that we need, it's difficult to know what speed feels the best until we have everything else that we want to implement. Okay, well, I will say that that appears to be working fairly well. Things are breaking, things are being fixed, tasks are being raised, tasks are being cleared. So I think, yeah, I think in terms of working, it's working. So now that we do have this working, the next step in the process really is to start adding these screens around the ship, one per department, and then start actually generating departmental tasks. And then these guys aboard the actual ship will, rather than just be roaming around doing arbitrary stuff, like pretending to work, they'll actually be picking up actual tasks and doing actual tasks from the task board, which is just another step in the direction of having actual jobs to do aboard the ship. Okay, well, I would say we have achieved all of our objectives, so it's a good time to call it a night. You guys should continue that debate on the Discord, and then we can mull it over somewhat. You're welcome, Frustus. And yes, I echo your thoughts. Okay, well, have a great one, everyone, and I shall see you on Friday. And I think on Friday, we'll probably do more of this, actually. We'll get it rolled out and see if we can start assigning tasks to players, because really that's the next step with this. We've got NPCs being assigned tasks, so players are next. And then we have, like, the beginnings of gameplay, which is good. Okay, well, on that happy note, I shall wish you farewell and see you on Friday. Bye!